This tutorial is a continuation of our discussion on moles and what information they can tell us. And in the first half of the tutorial, we discussed the equivalencies of moles to grams, meaning what is the equivalent value in grams of 1 mole of an element or 1 mole of a compound. But we said that moles can also tell us something about the number of atoms that are contained in a particular element and the number of atoms that can be in molecules in a particular compound as well. So let's discuss how we can convert moles to molecules and atoms. So the conversion factor that we're going to be using here is called Avogadro's number. It is a standard value, so there is nothing to actually calculate or determine before we begin the problem like we had to with the gram-mole conversions. And what we will do is use Avogadro's number as our conversion factor for both elements as well as compounds. Now the difference here being that 1 mole of an element is equivalent to this many atoms of itself. So 1 mole of an element is equivalent to 6.022 times 10 to the 23rd atoms. And that's Avogadro's number, and it is the same for atoms of any element. 1 mole of a compound is also equivalent to Avogadro's number, but in molecules. And that's a very, very important distinction to make. That Avogadro's number represents the number of atoms for an element, because elements are very simple. They're just made of or composed of atoms. But the Avogadro's number represents the number of molecules in complex compounds. That doesn't mean that we cannot attain the number of atoms that there might be in a compound, but we're not going to get there with Avogadro's number. So it's very important that you know that the mole values and their equivalencies to Avogadro's number will attain you the unit of atoms for an element and molecules for a compound. And it may seem trivial because it's just terminology, but it is a very important distinction. And the terms actually are specific and important and should not be confused. So let's take a look at a couple of examples here that we're going to try. And of course, we're going to utilize the gram to mole concept that we learned in the last tutorial, just so that we can help incorporate it into this next step. And the steps are that, of course, if we have grams, we can convert to moles using the atomic mass or the molecular mass. And from moles, we can convert to molecules using Avogadro's number. So let's take a look at this particular question. It asks, there are blank number of molecules and a blank number of hydrogen atoms and 130 grams of glucose, C6H12O6. So the first thing we need to determine is the number of moles, because they're asking us for molecules and atoms, and we know the only way to get to molecules and atoms is Avogadro's number. Well, we can't get to Avogadro's number unless we have a starting point of moles. So what we need to do is take these grams, this 130 grams, and go from grams first to moles. So here we go. 130 grams is the given times. We know that every 1 mole is equivalent to 180 grams of glucose. Again, add up the formula weight, and that should be 180 grams. And that is a 1 mole to 180 ratio then. The grams line up, and that would then give us the number of moles that we would have of glucose. 130 times 1 divided by 180. And again, that is using the mole to gram conversion factor. But we won't stop there because we're being asked for molecules. Good thing that we have mole, because then we can use the every 1 mole of a compound is equivalent to Avogadro's number worth of molecules. Again, the 1 mole will be on the bottom to cancel the mole on the top there. And finally, we'll say 130 times 1 times 6.022 times 10 to the 23rd divided by 180 will give us a number of the only unit remaining, which is molecules. That'll give us 4.35 times 10 to the 23rd. Again, from grams, convert to moles, and then moles using Avogadro's number to molecules. So this, we have 4.35 times 10 to the 23rd molecules of glucose in this 130 gram sample. Now the second part of the question has us take this step 1 further, which is from grams to moles to molecules, which we've already done, And then, of course, the last step, which is to help us solve for the number of atoms. And we're looking specifically for the number of hydrogen atoms. So how do we do that? We'll take this number of molecules that will be our given. We'll start off with 4.35 times 10 to the 23rd molecules of glucose. And we'll look at the formula here for glucose, C6H12O6. And we can see that in every one molecule of glucose here, we have in this box 12 hydrogens. That will be our new conversion factor right there. Every 12 hydrogen atoms is in one molecule. So looking for the new conversion factor of how many atoms of something are in one molecule is as simple as looking at the formula. So let's write our given. This many molecules times in every one molecule we have 12 H atoms. The molecules, of course, line up and cancel out, leaving us with hydrogen atoms. 4.35 times 10 to the 23rd times 12 divided by 1 is 5.2 times 10 to the 24th hydrogen atoms. So again, we had a gram to mole conversion, simple enough with a formula weight conversion factor. We converted from moles to molecules using Avogadro's number, and then from molecules to atoms simply by looking at the formula. Again, this particular problem was specific for hydrogen. Had this asked us for the number of oxygen atoms, for example, we would have seen that we have every 6 atoms in every one molecule, and this value here would have been 6 oxygen rather than 12 hydrogen. If it had not been specific at all and asked for the total number for all carbons, hydrogens, and oxygens, for all atoms in glucose, of course, we would have said we have 6 carbons, 12 hydrogens, and 6 oxygens. So 6 plus 12 plus 6, and that would have given us 24. So we would have said 24 atoms of X are in one molecule of glucose, and we would have solved for the total number of molecules, total number of atoms in a particular molecule of glucose. So again, it's a matter of following the steps. If you're asked for molecules, stop here. If you're asked for atoms, don't stop. Keep going until you have your last unit. And that's why writing the units is so helpful, not only in guiding you as to what you should place where, what to multiply and what to divide, but if you do box your answers and look at the values that you are attaining at the end and what their units are, you'll know what you have achieved in the problem and if you've indeed answered it. So at this point I have molecules, and if I had been asked for molecules, that'd be great. But if I was asked for atoms, of course, this would not be my ending point. I would have to go one further and get this answer. So hopefully this tutorial helps you in going from the steps of grams to moles to molecules, and of course down to atoms, and helps you in learning the equivalencies of grams to moles to molecules and atoms.